The problem was concrete. Soviet soldiers armed with Mosin-Nagant bolt-action rifles were being outgunned by the German Sturmgewehr 44, a selective fire weapon, intermediate cartridge, manageable in close combat. The Soviets needed to respond. In 1944, they opened a formal competition for a new automatic infantry rifle. Mikhail Kalashnikov was a tank commander sergeant recovering from wounds in Bryansk. He was not a trained engineer. He was a mechanic with the natural instinct who had seen firsthand what happened when enemy fire surpassed one's own. He submitted a design in 1946. He lost. He redesigned it incorporating elements of the long-stroke piston gas system, a rotating bolt arrangement, and simplified controls. He returned in 1947. This time, he won. The Red Army adopted the design as the Avtomat Kalashnikova Obraztsa 1947 Goda, the AK-47. The first production AK used a 1mm stamped steel sheet receiver. The logic was sound. Stamping was cheaper, faster, and consumed less material than milling. The Soviets wanted mass production from the beginning, but the post-war Soviet metallurgical industry had not mastered precision stamping at that scale. The rivets that joined the bolt guides to the receiver failed under sustained use and repeated automatic fire. The receivers warped and cracked at the stress points. The Army accepted it because it needed a rifle already deployed, not because it was satisfied with the result. They knew it had to be fixed. Type 1 confirmed the weapon's concept. It also confirmed that the design needed a completely different structural foundation. The solution was to step backward in the production process. The milled receiver was machined from a solid block of steel, heavier, slower to manufacture, more expensive per unit. But it did not fail. Type 2, introduced around 1951, adopted the milled receiver with some variations in the geometry of the bolt guides and the ejection port. Type 3, standardized around 1955, refined the external shape, added reinforcing side ribs, and established the recognizable silhouette of the classic AK-47. It is the one that appears in archival photographs, in war memorials, and on the walls of military museums across half the world. The total weight was around 4.3 kilograms without a magazine. The 415mm barrel fired the 7.62 by 39mm M43 cartridge. Functional accuracy out to 300 meters in the hands of a trained soldier. Type 3 was not perfect, it was reliable. For the Soviet Army, that was the absolute priority. The same Type 1 platform, but with a metal stock that folded downward and forward beneath the receiver. VDV paratroopers and armored vehicle crews needed a rifle that would not protrude in tight spaces. Tank compartments, transport cabins, aircraft doors. The AKS responded directly to that operational need without modifying the gas system, the bolt, or the feeding system. The folding mechanism was robust and simple to operate with one hand. It did not add significant complexity to maintenance or training. The Army adopted it alongside the standard model without hesitation. The metal folding stock would become a defining feature of multiple AK variants during the following decades. It established the pattern. Every generation of the rifle would have its folding stock variant from day one. The AKM was the most important change in the history of the platform. By the end of the 1950s, the Soviet industry had mastered precision steel stamping. The AKM returned to the stamped receiver, but this time, it worked. The 1mm sheet metal receiver was 22% lighter than the milled one. The difference was noticeable on every patrol. The slanted muzzle brake was a technically elegant addition. It directed the gases upward and to the right to compensate for the natural pull of the right hand during automatic fire, reducing muzzle rise and improving burst control. A hammer retarder added a minimal but measurable pause between the bolt returning to battery and the firing pin striking, improving reliability with cartridges whose primer might be slightly soft. The exterior finish changed to a matte black paint more resistant to corrosion under field conditions. The AKM became the most produced and copied rifle in history. Dozens of countries manufactured it under Soviet license or cloned it without one. China, Egypt, Poland, Yugoslavia, Romania, Finland. The original AK-47 was the prototype. The AKM was the reality of worldwide service. The pattern was already established. The AKMS applied the downward folding metal stock, inherited from the AKS, to the AKM's new stamped receiver, functionally identical to the AKM in every other aspect. Same barrel, same gas system, same bolt, same 762 by 39 millimeter cartridge. The reduced weight of the stamped receiver combined with the folding stock created the most compact and lightweight 762 by 39 variant up to that point. Airborne units, VDV paratroopers, and armored vehicle crews received the AKMS as standard issue. Its adoption was simultaneous with the base AKM. It was not a secondary or second echelon version. It was a parallel configuration designed for specific operational roles from the first day of production. Meanwhile, the spread of the AKM into the global non-military arms market was massive. The expiration of tacit export restrictions and Soviet foreign policy turned the AK into diplomatic currency. During the 1960s and 1970s, the AK flooded markets throughout the conflict-ridden world. Unlike the civilian AR-15, which grew through free market demand after Colt's patents expired, the AK spread through active state transfer. The result was the same: a global ecosystem of interchangeable parts, magazines, and ammunition produced in multiple countries and accessible to any armed actor on the planet. The AKM established the platform. The global market, legal and illegal, did the rest. The Soviets analyzed Vietnam closely. The American 5.56 by 45 millimeter cartridge produced flatter trajectories, less recoil, higher muzzle velocity, and better controllability in automatic fire than the 7.62 by 39 millimeter. The Soviet response was the 5.45 by 39 millimeter. Faster, flatter trajectory, lower recoil impulse per shot. The AK-74 was designed from the ground up around this new cartridge. The most visible and technically significant change was the double-chamber muzzle brake. Two gas expansion chambers separated by a central baffle reduced perceived recoil by approximately 40% compared to the AKM. Control in automatic fire improved drastically. The 415 millimeter barrel maintained the AKM's overall length, but with a 545 millimeter bore and a 1 in 200 millimeter rifling twist. The orange-brown polymer magazine, ribbed on its exterior for tactile identification in darkness, was immediately visually recognizable. The initial furniture was made of lacquered wood, progressively replaced by orange-reddish bakelite. Effective accuracy extended out to 500 meters with greater consistency than the previous caliber. The AK-74 was not a cosmetic revision of the AKM. It was a complete doctrinal change materialized in steel and polymer. Same principle, new generation. The AKS-74 added a metal stock that folded laterally to the left, different from the downward folding mechanism of the previous AKMS. The side-folding system proved more ergonomic when aiming with the stock folded and allowed for a more predictable overall length. Airborne units received the AKS-74 as standard issue alongside the fixed stock AK-74. The folded rifle measured approximately 490 millimeters, manageable during parachute jumps and inside transport vehicles. The simultaneous adoption of the AK-74 and the AKS-74 replicated exactly the pattern established in 1959 with the AKM and the AKMS. The Soviet Army did not wait to see whether the base design worked before committing to the folding variant. They adopted them together because operational needs could not wait. Alongside the AKS-74, Soviet engineers developed an ecosystem of integrated accessories. The GP-25 underbarrel grenade launcher, adopted in 1978, attached directly to the AK-74 without modifications to the base weapon. It added area fire capability at the individual level without additional tools. The PGO-1 red dot collimator, mounted through the receiver's standard side rail, was the Soviet equivalent of the first American ACOG optics. Later came the PSO-1 for the SVD sniper rifle, but its quick mount philosophy influenced the entire AK family. Soviet accessory doctrine was not as modular as the American SOPMOD, but it established that the AK was a platform, not just a rifle. That logic would fully materialize decades later with the AK-74M and the AK-12. The AKS-74U shrank the AK-74 to the limit of what the 5.45 by 39 millimeter cartridge could tolerate. The barrel went from 415 millimeters to 206 millimeters, just over 8 inches. The metal stock folded laterally like on the AKS-74. The result was a weapon measuring only 730 millimeters with the stock extended and 490 millimeters folded. The problems appeared quickly. The short barrel produced insufficient gas dwell times for reliable extraction with the standard configuration. The muzzle flash was massive. The detonation in enclosed spaces was deafening even with hearing protection. The solution was a conical muzzle moderator, an expansion chamber that allowed the gases to expand before exiting, reducing the muzzle flash and lowering the pressure at the muzzle. Afghanistan was the definitive combat test starting in 1979. Armored vehicle drivers, paratroopers, and KGB agents adopted it massively. It became iconic, identified by its unmistakable silhouette of an ultra-short barrel and cylindrical moderator. Soldiers called it Krinkov, although that name was never official. The platform proved that the AK could work in CQB at the cost of range and muzzle velocity. The same trade-off as the American XM-177, resolved through different means. The RPK was the logical extension of the AKM into the squad light machine gun role. The same stamped receiver, the same gas system, the same bolt, but with a heavier, non-removable 590mm barrel, a fixed stock with an integrated cheek rest, and a folding bipod beneath the handguard. The additional barrel weight improved heat management during sustained fire. The 40-round magazines and 75-round drums were compatible with squad rifles. The RPK-74 repeated the same formula with the 5.45 by 39mm cartridge when the AK-74 arrived, a 590mm barrel, bipod, 45-round magazines, and 60-round drums. The logic was the same that guided the entire AK family: share parts, simplify logistics, train with a single system. A squad soldier could operate both the individual rifle and the support weapon without significant retraining. That interoperability was a real tactical and logistical advantage. The AK-74M solved a fragmentation problem. The Soviet Army operated simultaneously with fixed stock AK-74s, folding stock AKS-74s, and variants for different units. The AK-74M unified everything into a single model. The black polymer stock could fold laterally to the left or remain extended with equal structural solidity. It was no longer necessary to manufacture and stock two separate variants. The complete furniture changed to black polymer, including the pistol grip and handguard. The standard side rail on the receiver allowed the PGO-1 collimator or other Soviet optics to be mounted without modifications. The muzzle device was compatible with GP-25 and GP-30 grenade launchers. The AK-74M entered active service in 1991, the same year the Soviet Union was dissolving. The Russian Federation inherited it as its standard rifle and continued producing it. It became the foundation of the entire later modern AK family, the A1 of the AKM, the platform upon which everything that followed was built. Advances in materials and surface treatments accompanied this unification. Russian manufacturers adopted black phosphating and later polymer dip coating for greater corrosion resistance. Barrels began receiving more precise internal chrome lining treatments, extending service life under intensive use conditions. Higher quality stamped steel receivers reduced dimensional variations among production units. Key internal parts, such as the bolt carrier and bolt, underwent more controlled surface hardening processes. In the civilian and export market, manufacturers such as Arsenal of Bulgaria, Radom of Poland, and Izhmash of Russia began offering variants with improved finishes, high-strength polymers, and barrels with tighter production tolerances. These changes did not alter the fundamental architecture of the AK. They refined durability and reduced maintenance without touching the core design. The Russian Federation needed foreign currency, and international customers had different calibers. The solution was the AK-100 series, the AK-74M platform in multiple caliber and barrel length configurations. The AK-101 and AK-102 fired 5.56 by 45mm NATO for Western markets. The AK-103 and AK-104 returned to 7.62 by 39mm for customers with existing stocks of Soviet ammunition, including Venezuela, India, and several African countries. The AK-105 was a carbine chambered in 5.45 by 39mm, with a 314mm barrel. All shared the same architecture: AK-74M stamped receiver, folding polymer stock, side rail, black furniture. The AK-100 series was not a technical revolution. It was a commercial and foreign policy decision executed with the same proven platform. Kalashnikov concern could serve almost any customer without redesigning the weapon from scratch. The evolution of magazines was parallel and significant. The AK-74M's 30 and 45 round polymer magazines improved dimensional consistency compared with the first Bakelite designs. The RPK-74's 60 and 75 round drums proved compatible with infantry rifles in situations of need. Manufacturers of the AK-100 series introduced higher angle followers and more durable springs to reduce feeding failures in dusty and sandy conditions. In the export market, steel magazines for 7.62 by 39 mm versions received coatings with greater impact resistance. Magazine reliability and ammunition compatibility among variants of the same caliber remained design priorities. Just as interoperability had been the AK's central logistical argument since 1947, the AK-107 represented the Soviet and later Russian attempt to solve the AK's fundamental problem: the recoil generated by the long-stroke piston system moving the mass of the bolt. The solution was a balanced recoil system with two piston masses moving in opposite directions simultaneously. A counterweight moved forward while the bolt moved backward, canceling the impulses. The result in test firing was a drastic reduction in weapon movement during automatic fire and improved burst accuracy. The technical results were real and measurable, but the Russian army never adopted it at scale. The system added mechanical complexity, additional weight, and higher manufacturing costs. The tactical advantage did not justify the logistical cost compared with the massive number of AK-74Ms already in service. The AK-107 demonstrated that it was possible to make the AK significantly more controllable. It also demonstrated that technical viability and military adoption are two completely different things. The AK also proved to be adaptable to roles requiring greater precision than those assigned by its original doctrine. With selected barrels featuring tighter dimensional tolerances, tuned triggers with lighter trigger pull, and precisely fitted magazines, competition AK-74Ms achieved consistent groups at 300 meters that would have surprised the engineers of Izhevsk. Romanian Romarm and Bulgarian Arsenal versions, with cold hammer-forged and chrome-lined barrels, demonstrated that the AK's broad tolerances did not prevent accuracy. They simply prioritized reliability over it. The Dragunov SVD sniper rifles, which share the rotating bolt family with the AK, carried that logic to its natural conclusion. The modularity of the AK platform did not reach the AR-15's roll flexibility, but the reliability of the long-stroke gas system proved to be equally applicable to precise long-range fire when the manufacturer chose to optimize in that direction. The AK-12 arrived after a long and politically complicated competition. The first 2012 prototype had full ambidextrous controls, a telescopic stock adjustable in length of pull and cheek rest, and Picatinny rails integrated into the upper receiver. The Russian military evaluated it for years. The original design was rejected or significantly modified before formal adoption. The version adopted in 2018 as part of the Ratnik individual equipment integrated a Picatinny rail over the receiver for red dot sights and optics without the need for side adapters. The modular handguard accepted accessories in multiple positions, although the specific implementation of M-lock or side rails varied among production variants. The stock folded laterally and adjusted in length. The fire selector added a 2-round burst position in addition to automatic and semi-automatic. The gas system retained the long-stroke piston, the same Kalashnikov principle, refined in tolerances. Military testers documented greater reliability, better burst accuracy, and improved ergonomics compared with the AK-74M. The AK-12 marked the first fundamental ergonomic revision of the original design in decades. It did not change the weapon's DNA. It modernized the soldier's interface with it. The AK-12's ambidextrous controls closed a gap that Kalashnikov's original design had never addressed. The original AK fire selector operated only on the right side, and its long travel was a constant critical characteristic for left-handed shooters. The AK-12 added a selector lever on the left side a bolt catch accessible with both hands, and a charging handle that could be moved to the left side. The four-position length of pull-adjustable stock accommodated shooters of varying heights for the first time without gunsmith modifications. These changes added real improvements in handling under stress and in clearing malfunctions while wearing heavy equipment. Ambidextrous ergonomics arrived on the AK-7 decades after its original design, but it arrived incorporating lessons from decades of real combat across multiple theaters. The AK-12's experience in Russian operations in Ukraine generated direct field feedback. The 2023 revision simplified the selector by eliminating the two-round burst position, returning to three positions: safe, semi-automatic, and full automatic. Soldiers in active combat reported that the additional position created tactile confusion under stress. The logic was the same as the M4A1 over the M16A2. In real combat, soldiers want a simple and predictable fire control. The revised version retained the integrated Picatinny rail, the adjustable stock, and the modular handguard. It also incorporated minor improvements to the bolt and extractor based on wear observed under intensive use conditions. The 2023 revision was not a redesign. It was the Russian army learning the same thing the American army had learned decades earlier. Fewer options on the selector equals more control under fire. Suppressor integration and excess gas management also became active considerations during this period. Suppressing the AK presents particular challenges because of the higher gas pressure of the long-stroke system compared with direct impingement designs. Some manufacturers of the AK-100 series and the AK-12 began implementing gas blocks with a two-position regulator, allowing the shooter to reduce the volume of gas reaching the system when a suppressor was attached. This reduced excess gas in the receiver, accelerated wear, and the additional fouling inherent to suppressed firing. Gas regulation in the AK represents the same trend observed in American M4A1s, with adjustable gas blocks. The recognition that a system tuned for unsuppressed firing needs readjustment when a suppressor enters the equation. The AK reached this conclusion later than the AR platform, but it arrived there for the same operational reasons. The AK did not need a program equivalent to SOPMOD to spread globally. It spread through more direct channels. The Soviet Union transferred manufacturing technology to Warsaw Pact allies. Poland, Czechoslovakia, Hungary, Bulgaria, Romania, and the German Democratic Republic produced their own variants under Soviet specifications. China received the technology in the 1950s and produced the Type 56, which reached North Vietnam, insurgent groups in Africa, and multiple Cold War proxy conflicts. Egypt and Finland manufactured high-quality variants. Yugoslavia developed its own line with distinct characteristics, including a different pistol grip and barrel variants. Logistics was the most powerful argument. Any army, militia, or resistance movement that captured 7.62 by 39 mm or 5.45 by 39 mm ammunition could feed its AKs. This universal logistical interoperability made the AK the dominant weapon of asymmetric conflict in the 20th century and much of the 21st. In recent decades, the modernization of the AK through modular mounting systems replicated the same transition that the AR experienced from the quad rail to M-lock. Aluminum handguards with full Picatinny rails gave way to polymer and aluminum handguards with key-mod and M-lock slots in multiple positions. Manufacturers such as Zenitco, CAA, and several Bulgarian and Romanian producers offered free-float handguards that eliminated contact between the accessory and the barrel, improving accuracy under accessory load. The AK's standard side rail, inherited from the AK-74M, allowed the integration of optics without modifying the receiver. The AK accessory ecosystem reached a level of maturity in the 2000s that made it operationally comparable to that of the AR, although always within the philosophy of broad tolerances of Kalashnikov's original design. Today, the AK-12 in 5.45 by 39 mm remains Russia's standard frontline rifle, but Russian research has explored intermediate cartridges like 6.02 by 41 mm and 6P67 for greater penetration. None have been adopted, yet this shows Russia faces the same doctrinal pressure as the US. The 5.45 mm, like the 5.56 mm, is questioned at ranges beyond 500 meters against modern body armor. The AK-12 is not the final version. It is the latest link in an ongoing evolution similar to the AR-15/M16. In civilian and export markets, the AK has diversified calibers like the AR-15. 7.62 by 39mm versions remain in production, and 5.56 by 45mm AK-100 series serve NATO-compatible customers. U.S. manufacturers like Century Arms and Arsenal USA produce AKs in additional calibers, including 300 Blackout. Material improvements, nitrided barrels, nickel-boron coatings, durable finishes have extended cleaning intervals and reduced maintenance, while the AK's reliability has been enhanced without altering its core design. So, what changed and what stayed the same? What changed? Receiver from milled to stamped, caliber from 7.62 to 5.45, furniture from wood to polymer, accessories from nothing to Picatinny rails, ergonomics with adjustable stocks and ambidextrous controls, and gas regulation now adjustable for suppressors. What stayed the same? The long stroke piston, rotating bolt, curved magazine, broad tolerances that favor reliability over accuracy, and the core logic of a weapon any soldier can keep running in any condition. By the mid-2020s, the AK-74M remains the standard rifle for most Russian forces simply because there are so many in inventory. The AK-12 is being issued, but has not fully replaced the older model, so Russia operates multiple generations at once. This is not a failure, but the natural result of building a weapon so reliable and cheap that there is never a pressing need to retire it entirely. Looking ahead, expect more modular handguards, more adjustable gas systems, and wider suppressor use. But the AK's fundamental DNA from 1947, robust gas system, loose tolerances, simplicity, and easy mass production, remains completely intact. Everything else is just refinement around that core. That's all for today. I hope it was interesting. Thank you all for watching. See you.